All right. So basically, the conjugate root theorem, the complex conjugate root theorem, is something we already know. Ultimately, we know if a root is imaginary, like let's say I is a root, what has to be another root? Negative I, right? We know that the imaginary roots come in pairs. And that's essentially all that this theorem is saying. So let's write that out. So it says if an imaginary number is a zero to a function, then its conjugate is also a zero. If the coefficients of the polynomial are real numbers. Why do you still need your borders, Justin? Okay, so an example would be if 2i is a zero, what's the other zero? Then negative 2i is also a zero. If 1 plus I is a zero, what's the other zero? Any guesses? Stephen? Nope, just 1 minus I. You're just taking the conjugate, just changing the sign, that's all. So if 1 plus I is a zero, then 1 minus I is also a zero. All right, let's do a sample problem. So the first one, it's saying if 1 plus I is a zero, of x to the third minus 3x squared plus 4x minus 2, find the remaining two roots. I'm going to show you two different ways we could do this. Okay, so the first way, I'm going to say if root 1 is 1 plus I, what does the second root have to be? 1 minus I. Because remember, the imaginary roots come in pairs. So my game plan here, now that I know 2 out of the 3 roots, how do I know that it's 3 roots? because they gave us one root and they said find the remaining two roots, which means I have to have 3 roots in total. So I knew that imaginary roots come in pairs. So I have 1 plus I have 1 minus I. My game plan here is I'm going to use the sum and product that we learned yesterday to find the factor that gave me these 2 roots. Once I find that factor, what do you think I could do with that factor and the original polynomial to find the remaining root? So like, for example, if my number is 14, I know 7 is a factor. How do I find the other factor that goes with 7? Oh, yeah? You divide it. So wouldn't I do 14 divided by 7 and then I'd get 2 as the other factor? So that's exactly what I'm doing here. So this is my product, right? I'm going to find one factor from these 2 roots. Once I get that factor, I'm going to take my original polynomial, I'm going to divide it by this factor to find their other factor. So this is the game plan. Let's do it now. So I'm going to use the sum and product that we learned yesterday. Root 1 plus root 2 is going to give us negative b over a. So I have 1 plus I plus 1 minus I, which is just 2 over 1, be negative b over a. So this tells me my a is 1. If 2 is negative b, what's positive b? Stephen? Negative 2. Is this enough to find the factor that gave us these 2 roots? No, I need a c. So how am I going to find c? I have a and I have b. What do I do to find c? Tyler? You got it. So now I use the sum of roots to help me find a and b. Now I'm going to use the product of the roots, root 1 times root 2, to give me c over a. So I have 1 plus I times 1 minus I. Now remember, when I multiply these conjugates, it's not a squared minus b squared. Because of the I, doesn't it end up becoming a squared plus b squared? So it becomes 1 plus 1, which is 2. So go back up here. I know a is 1, b is negative 2. What is c? 2. So the factor is going to be x squared minus 2x plus 2. That's the factor that gave us 1 plus I and 1 minus I as our roots. So what did we say we were going to do with this factor to find the last factor? Stephen? You got it. So give us our original polynomial, x cubed minus 3x squared plus 4x minus 2. And I'm going to divide that by x squared minus 2x plus 2. And now we perform our long division. X squared times what will give me x to the third? X, you got it. Now I'm going to take that x and I'm going to distribute it into the divisor. X times x squared is x cubed. X times negative 2x is a negative 2x squared. X times 2 is a 2x. Now we're going to subtract. But remember, because I'm subtracting that whole quantity, what do I have to do to all the signs? Change them. I have to distribute in the negative. So that becomes a negative x cubed, a positive 2x squared, and a negative 2x. So the x cubes cancel. I'm now left with a negative x squared plus 2x, and then I'm going to bring down that minus 2. So now we ask ourselves, x squared times what gives me negative x squared? Negative 1, you got it. Now I'm going to take that negative 1, I'm going to distribute it into the divisor. So we get a negative x squared plus 2x minus 2. And now once again, because I'm subtracting that whole quantity, I have to distribute in the negative, which changes all of the signs. And once I distribute in that negative to change all the signs and I add, what happens? Everything cancels to 0. Should everything cancel to 0? Yeah, because it is a factor, right? And if we ended up with a remainder, would it be a factor? No. So if we ended up with a remainder, you knew something went wrong. Something went wrong within the sum or products, or something went wrong in the division. But it should have a remainder of 0 because it is a factor. Yes. Yes. Okay. So now we know x minus 1 is another factor. So how will I find the root that x plus 1 will give us? What do I do? So this is another factor. How do I find the root that comes from that factor? We set it equal to 0 and do what? Solve. So x equals 1. So my roots that they asked us to find, we know the first one is root 1 is 1 plus I. X equals 1 plus I, 1 minus I, and 1. These are the roots. Does anybody have any ideas how else, looking back at this problem, how else we could have found the remaining roots? Well, we already knew 1 was the conjugate, right? So we already had 1 plus I. We immediately know 1 minus I is a root because the imaginary roots come in pairs. Any ideas a different way we could have found that third root? Pranav? We could. Pranav, what are you doing on your computer? Okay, good. Pranav is correct. We can use synthetic substitution. So what we're going to do is every time we use synthetic, how many degrees does it go down? 1 degree. So I'm going to use, so this is another way we could have done this. So I'm going to put 1 plus I in the box. And every exponent's accounted for, so we're okay. I have 1, -3, 4, and -2. Bring down the 1. 1 times 1 plus I is 1 plus I. -3 plus a 1 plus I is a -2 plus I. Now this one takes a little bit of work. I need to actually FOIL this out. 1 plus I times -2 plus I. 1 times -2 is a -2. 1 times I is I. -2 times I is a -2I. I times I is an I squared. So we're -2 plus I minus 2I plus 1. So now we're left with -1 minus I. All right, now we have -4 plus a -1 minus I gives us a -3 minus I. So now I'm going to have, oh, what did I do? Oh, it's a -1. Good catch, guys. So then this would be -3 minus I, which makes this -3, which makes this 1 minus I. Oh, that's better. Okay, and now I have an a plus I times an a minus I. Isn't that just a squared plus b squared? So 1 plus 1 is 2. And there's our 0. So now I'm going to do, so now this brought me down to a degree of 2. I'm going to do synthetic one more time with my other root. Now, when I use synthetic again, am I using my original coefficients or the new coefficients? The new coefficients. Bring down that 1. 1 times the quantity of 1 minus I is 1 minus I. This ends up giving me a -1. -1 times the quantity of 1 minus I is a -1 plus I, which then gives me 0. So now I'm down to a degree of 1. So this becomes x minus 1 equals 0. So x will equal 1. That's using synthetic. I will not tell you what way to use on the test. So you're going to look at the problems and you're going to solve it however you want to solve it. All right, ready for another problem? Ethan, I don't like you back there. I don't know. I just don't. It makes me sad. Okay, so I want us to find find a third degree polynomial function with real coefficients if two zeros are 2 plus I and 5. So if root 1 is 2 plus I, what's root 2 have to be? 2 minus I. And root 3, they told us, is 5. So now what I'm going to do is I'm going to use the first two roots and use sum and product to find the factor. I'm not going to use sum and product to find the factor of this third root. First, I have nothing to pair it with. But secondly, if the root is 5, what's the factor that gives us 5? You got it. This means x equals 5. So the factor is x minus 5. So I already have this factor. So now that I know this factor, and I'm going to find this factor, what will I do once I have both factors? You got it. Multiply it out together. All right, so let's use our sum and product. So we know root 1 plus root 2 will be negative b over a. So this is just going to be 4 over 1 equals negative b over a. So our a is 1, our b is negative 4. And then the product, root 1 times root 2, is going to be c over a. So we're going to have a squared plus b squared. So that's 4 plus 1 is 5 over 1 equals c over a. So our c is 5. So our factor is going to be x squared minus 4x plus 5. And now we're going to multiply the factors together. So I'm going to have x minus 5 times x squared minus 4x plus 5. X times x squared is x cubed. X times negative 4x is a negative 4x squared. X times 5 is 5x. Negative 5 times x squared is a negative 5x squared. Negative 5 times a negative 4x is a positive 20x. And negative 5 times a positive 5 is a negative 25. Let's combine our like terms. X cubed minus 9x squared plus 25x minus 25. Now, did I ask for an equation? Did I say find the equation? No, what did I say? Find the polynomial function. So we're going to call this p of x. That's our polynomial function. If I had said not the polynomial function, if I had said find an equation, then what would I have done? I wouldn't have said p of x equals. What would I have had to do? Equals 0. You got it. All right, next one. So this time we're going to find fourth degree polynomial function with real coefficients if the roots are 3i and 1 plus I. Okay, so if root 1 is 3i, what's root 2? Negative 3i, good. If root 3 is 1 plus I, what's root 4? 1 minus I. Any ideas on what I should do? Any guesses? Find our factors how? Tyler? And use what? Yep, exactly. So I'm going to use sum and product for these two roots, and then I'm going to use sum and product again for these two roots, and that's going to give us the factors that Maya said we should find. And then once I find those two factors, then what should I do? Multiply them together. Exactly. So let's do root 1 plus root 2. That's going to be 0 over 1, right? 3i plus a negative 3i is 0. That's okay. That is allowed. That's negative b over a. And then I'm going to have root 1 times root 2 is going to give me negative 9i squared. Isn't that just positive 9? Which is c over a. So here our a is 1, our b is 0, and our c is 9. So this gives us x squared plus 9 is the factor. Okay, now I'm going to use sum and product on the remaining two roots. So we have root 3 plus root 4 is going to be 2 over 1, which is negative b over a. And now I have root 3 times root 4, which is a squared plus b squared. That's just, again, 2, and that's c over a. So my a is 1, b is negative 2, and c is positive 2. So this factor is going to be x squared minus 2x plus 2. And what should I do? Multiply together now. Multiply the factors. So I have x squared plus 9 times x squared minus 2x plus 2. If we multiply these together, we are going to get the polynomial function of p of x equals x to the fourth minus 2x cubed minus 7x squared minus 18x minus 18. Did I multiply wrong? I might have multiplied wrong. It's a positive 7x squared. Oh, so I added wrong. I didn't even just multiply wrong. Like that.
It's also
At the end.
yeah. Oh yeah.
Positive 9 times positive 2 is a positive 18. You're right. Now is this right? Sorry. All right, let's keep going. So now I'm going to switch it up a little bit. Given 2 minus 3i is a 0 of x to the 4th minus 4x cubed plus 14x squared minus 4x plus 13. Find the remaining roots. Well, if root 1 is 2 minus 3i, what does that mean for root 2? It has to be 2 plus 3i, which means how many roots are left to find? 2 more. A couple of different ways we can do this. What's one way we can do this? Rika?
We saw this as in the last one. And that equation, then that one divided by.
Perfect. So one way we can do this is we can use these two roots to find the factor that gave us these two roots. Once we find the factor, I can then take this factor and divide it into the original polynomial function. That will give us the last factor. And once I have the last factor, what can I do with that? Factor it, solve it, figure it out, right? I could do that. What's another way we can do this? Synthetic, how many times? Twice. That will bring me down to a degree of 2. And then what should I do? Factor or quadratic or whatever it is. All right. So I'm going to use, since this is mostly based on sum and product, I'm going to use the sum and product. So we're going to use SMP. Root 1 plus root 2 is going to be 4. So that's negative b over a. And then root 1 times root 2 is going to give us a squared, which is 4 plus b squared, which is 9. 4 plus 9 is 13, not 19. Oh, 13 over 1, which is c over a. So this tells me my a is 1, my b is negative 4, and c is 13. So the factor is going to be x squared minus 4x plus 13. Are we good with that? Now, what did we say we were going to do with this factor? Good. Divide it into the original. So now we're going to have x squared minus 4x plus 13, and we're going to divide that by, oops, sorry, wrong setup. This should be x to the 4th minus 4x cubed plus 14x squared minus 4x plus 13. And we're going to divide that by x squared minus 4x plus 13. And now we divide x squared times what gives us x to the 4th? X to the 2nd. X to the 2nd times x to the 2nd is x to the 4th. X to the 2nd times negative 4 is a negative 4x cubed. X to the 2nd times 13 is 13x to the 2nd. Because we're subtracting, we have to distribute in and change all of our signs. So the x to the 4th cancels, the 4x cubes cancel, and now I'm left with just x squared minus 4x plus 13. So x squared times a positive 1 will give us x squared. So now we distribute in that positive 1. And because we're subtracting, we need to change all of our signs, and everything cancels as it should. So now the factor is x plus 1. How do I find the root that goes with that factor? x squared plus 1. What do? X squared plus 1 equals 0. So then x squared equals negative 1, square root both sides. X will equal plus or minus I. So now I want all the roots. So all the roots are going to be x equals 2 plus 3i, 2 minus 3i, and plus minus I. Is it okay that all 4 roots are imaginary? Is that okay? Yeah, perfectly fine. All right, last question for today. Yeah, of course. Rika just said, can we write 2 plus or minus 3i and plus or minus I? Of course you can.
I was.
You didn't look stupid. Don't say that.
Oh.
All right, so now I'm adding in another layer here. Find the polynomial with zeros of 4 and 2 plus I, and P of 1 has to equal 5. Ooh. Justin brought down his border for this question. It's serious. Okay. Ignore the P of 1 equals 5. Let's just put that on the back burner right now. Let's go ahead. Let's find the polynomial with zeros 4 and 2i. So if root 1 is 2 plus I, what does that mean for root 2? It is 2 minus I, and then root 3 has to be 4. Well, because root 3 equals an integer, what do we know? The factor has to be x minus 4. So we're good there. So I found the factor of 4, the root of 4, the root that equals 4. How am I going to find the factor that gave us 2 plus or minus I? Just beat the sum and product. Do you see why this lesson made so much more sense in this chapter than last chapter? Okay, so sum and product. So root 1 plus root 2 is going to be 4. Root 1 times root 2 is going to be 5. So my A is 1, our B is negative 4, and our C is 5. So we're at x squared minus 4x plus 5. What should we do now? Multiply. It's very repetitive, right? I don't know where's the other one? X minus 4, okay. Can somebody tell me what they got when they multiplied this? Is it x to the third minus 8x squared plus 21x minus 20? Yeah? Okay. So this is the polynomial that gives us those 3 roots. But I added another layer in here. What did I say? We also need P of 1 to equal 5. What does that mean? So if this is our polynomial function, P of x, what does it mean when it says P of 1 equals 5? Maya. Good. When I plug in 1 for x, it should simplify down to 5. Let's see. One cubed minus 8 times 1 squared plus 21 times 1 minus 20. 1 cubed is 1 minus 8 plus 21 minus 20. 8 minus 1 1 minus 8 is a negative 7. 21 minus 20 is a positive 1. Isn't this a negative 6? Does negative 6 equal 5? No. So what does that mean? That means there is a GCF in front of my polynomial function, or I have to create a GCF in front of my polynomial function for this to simplify down and to be 5. So let's put a GCF in there. So now we're going to say k times x cubed minus 8x squared plus 21x minus 20. We need this to equal, well, when we plug in, we need it to equal 5. So now we're going to plug in 1 again. 1 cubed minus 8 times 1 squared plus 21 times 1 minus 20. Do we already agree that we know this simplifies in the parentheses down to negative 6? And what do we need this to equal? We need it to equal 5. So guess what I'm solving for? Okay, so what do I do? Divide by negative 6. So what does that mean? Our GCF has to be negative 5 over 6. So our polynomial function is going to be negative 5 over 6 times x cubed minus 8x squared plus 21x minus 20. Do you want to do one on your own, or do you want to call it a day? All right, I'm in line with that. I'm good.